Roy Choudhury, Assistant Vice President Sales of Arctic Division at Desiccant Rotors International Pvt, based out of Gurgaon and Ahmedabad. He has been associated with us for a decade with the company, with technical sales experience of around 4 decades. With over a decade of experience in HVAC product sales, he is handling pan-India operations of the sales team, dealers network and service providers. Mr. Debashish has an MBA in sales with a PG Diploma in International Trade. Today, Mr. Debashish will give us a brief view on option air cooling for large spaces. So delegates, let's welcome Mr. Debashish.
My session will be a little basic, not much of technical, because the subject is such. I am today here with evaporative air cooling. These are my details, my phone number and my email ID. If anybody wants to get in touch with me, this is where I can be found. Talking of thermal comfort, let me just very briefly tell you, ask you whether it's a luxury or a necessity today. It is a necessity, naturally. Why? Because it would enhance the overall quality of life, productivity and well-being of humans. So achieving and experiencing thermal comfort is essential for human psychology and physiology well-being too. This is determined by the temperature, RH, airflow, air temperature, dew point temperature, wind speed, insulation, individual's clothing and metabolic rate. Okay, so all this will affect the thermal comfort of humans mainly. Now, my subject, what is evaporative cooling? Evaporative cooling is a very old technology, age old, like it was there before fan came in, before ACs came in, even before electricity came in. The example of evaporative cooling would be a water pot, a mud pot filled with water. Water is always more cooler in the mud pot than any other vessel, because water droplets come out of the pores of the mud pot. As soon as they come in contact with the ambient, it would evaporate, the droplets would evaporate and vessel would become cooler. Hence the water inside is cooler. Another example is a swimmer. When he comes out of the swimming pool, tiny droplets of water all over his skin evaporate, he would feel cooler. So this is evaporative cooler. Dr. Murthy also spoke about this, about the old buildings which had water bodies around, water bodies inside also. So they are all examples of evaporative cooling. Now we'll just throw some light on the Indian conditions and air. As it was shown earlier, a map of India, it can be effectively distributed into two major climatic zones. One is hot and dry and composite. It covers the majority of the country. So leaving aside the coastal line, which is humid, majority of India comes in these zones. And evaporative air cooling is an effective alternative technology using substantial and affordable non-GWP refrigerant-based cooling. We work on simple principle of evaporation of water, where water is the refrigerant. 100% fresh air from outside is cooled, filtered, and brought in to remove heat, odor, vapor, etc. These equipments are cost-effective. Initial cost would be 50 to 60% of an air conditioner, and about 85 to 90% running power would be less. Running power, I mean, by running cost, I mean power consumption as compared to other mediums of cooling. This is India. This map we have seen just now. The central part of India, this whole central part is very hot and dry. This is most hot and dry. These are again coastal areas, so moist climate. But all these places, most suitable is evaporative cooling. In these areas also, but they are for different applications. These are few temperatures recorded, highest temperatures recorded in major cities of India. You can just check Jammu, which is in Jammu and Kashmir, 45.8 degree has been recorded. And every year this is increasing. Baddi, it's 40 degree. Baddi is Himachal. Delhi, 47.8. Jaipur, 46. Alodi in Rajasthan, 51 degree. Kanpur, 46. Indore, 44. Nagpur, 47. Hyderabad, 43. And these are increasing every year. So ambient temperatures are very high all throughout India. Now, after evaporative cooling, what happens? We take the example of, say, Ahmedabad. This is the average summer temperature. Reliable temperature is 42.1, and after passing through evaporative cooling, direct evaporative cooling or single stage evaporative cooling, temperature drop can be up to 24.9 degree. So roughly a temperature drop of 17 degree is possible. Direct cooling in places like Ahmedabad. Now these are all the temperature drops. If you see, this is one of the highest. It's in Rajasthan. Jaipur can, by direct evaporative cooling, temperature drop of 19.1 degree can be achieved in Jaipur. In Nagpur, 19.3, and so on. Even some few places of Gulf also, in Riyadh, 22.9 degree can be possible. You can see by evaporative cooling, at least comfortable temperatures are possible. What are the application? Application area number one is for human comfort. Human comfort means everywhere where humans are there. Second application would be heat removal. Wherever there is more heat, through evaporative cooling, heat can be removed. Like we bring in fresh air, so the air inside has to go out. When it goes out, the heat is removed. And then you have process needs like textile, tea industry, paper and packaging. There you need more moisture. For animals, I've been talking about humans, but evaporative cooling can also be done for animals, for birds, and for plants. So it's a huge segment through evaporative cooling. And for public areas, this is the only cooling possible, I'm sure, which can be done for open areas also. So open areas, gardens, gyms and stadiums, bus stands, BRTS bus stands, railway platforms and metro stations, and many more open areas. These are examples of few of our installations in open areas. This is incidentally today the Mahakal temple is being revamped. So this is a picture of Mahakaleshwar temple in Ujjain, where we had done air cooling. The area where people stand and see the Aarti, that has been air cooled by us. This is that area, and this is our duct. These are the machines, small coolers put in a row, and this is the duct. So we cool a large number of people in an open area, seeing Aarti every day, Mahakaleshwar. This is a company canteen. This is in Rajasthan. Canteen again, there is lots of heat and they want cooling very fast, for maybe 2-3 hours only. So this is a very good installation that we have done. This is a factory, same industry. Same company. This is a farmers cooperative union in Nasik, which is air cooled by us. This is many such installations. There is a departmental store in Sangli, huge departmental store. Restaurants, all open air restaurants, rooftop restaurants, garden restaurants, banquet halls, they can be air cooled. These are again public places. This is in hospital. Common areas of hospital, general wards can be air cooled. This is a masjid. So all such places of worship, masjid, churches, gurudwaras, temples, they can be air cooled. This is a mall. So mall, the common area of mall where purchases don't happen. Only people come, sit and maybe pass their time. These are the areas where not much of expenses can be done, and normal air cooling also is possible. It's a unique installation. It's a petrol pump. So petrol pump where people come to fill petrol for maybe a few minutes. There also they can have evaporative cooling and comfort. These are few installation pictures of evaporative cooling. So a short presentation. Thank you so much.